Hi guys, in this video we're going to talk about something that's called inverse functions. So I'm just going to give you a brief sort of idea what an inverse function is and how we are then going to calculate it for the functions on our course. So I want you to go back all the way to first year maths, and if I look at a plus here, then hopefully we are quite happy that in order to undo a plus, i.e. the inverse of a plus or adding something, is to subtract it or to minus it. Likewise, if I look at the times sign, so if I have, say, something times by 5, in order to undo it, I have to do the opposite, or the inverse, which is to divide it by 5. Likewise, if I have a square root, I have to square it. And then this is an interesting one, because we've all seen the trigonometric ones now. If I have sine of an angle, in order to undo this sine, if you remember on your calculator, you'll see the sine to the minus 1. An inverse sine, and that there is its inverse function, and that allows us to get the variable if it's stuck in a sine, a cos, or a tan. So for example, if I just show you very quickly what I mean, so what we have here is we have sine of theta is equal to a half. You can see here that the variable theta is stuck in the sine function. So what we do is we do the inverse sine function, so we've got sine to the minus 1, which we then have to do to the other side, so sine to the minus 1 on the other side. And on the left hand side, what we still have is we still have this sine theta, and on the right hand side we have this half. Now this sine 1, or sine to the minus 1, and this sine here, this is an inverse function with the function, which, just like the positive and the negative, will actually cancel everything out, leaving us with just theta. And then what we do, we get our calculator, and because we've sine to the minus 1, we've inverse sine the left hand side, we have to inverse sine the right hand side, get our calculator out, and we put that into our calculator, and we get theta is equal to 30 degrees in this case. So if we have a look at this on a mapping diagram, you can see that for a function here, whatever the function happens to be, it doesn't matter. We see that 1 maps onto 5, 2 maps onto 7, and 3 maps onto 7. And the inverse function is essentially going in the different direction. Notice how we're going from the x to the y here. This is the input essentially to the output. For the inverse function, what we're doing is we're going backwards. So notice how 5 maps onto 1, and 7 maps onto 2, and 7 maps onto 3. So we're going like backwards through the function. We're undoing what we did. 1 mapped onto 5 here. The inverse function, 5 maps back onto 1. So let's have a look at this function here. We have x maps onto y, which is shown in this arrow diagram here. And we've got 1 maps onto 5, 2 maps onto 7, 3 maps onto 7. And you can see here that what we have again here is we're going to go the opposite direction here. See that 5 maps onto 1, 7 maps onto 2, and 7 maps onto 3. This is the inverse function. Notice that the arrows essentially have just been turned round. So if we wrote these as a set of couples in this direction, we get 1, 5, 2, 7, 3, 7. That's written there. Notice if we're going in the opposite direction, so the inverse function, we're going 5 to 1, 7 to 2, and 7 to 3, which here you can see 5, 1, 7, 2, 7, 3. And just like the notation before with the sine to the minus 1, hopefully you can see that what we do is write f to the minus 1, and that tells us that that there is an inverse function, as you can see written down here. So how do we find the inverse of a function? Well, it's actually quite easy. So we'll do an example just to show you. So what we have here is we have f of x maps onto 2x plus 5. And here you can see from our mapping diagram, there's our input going into our output with y is equal to 2x plus 5 as our rule. So if I put, for example, 2 in here, I get 2 times 2, so my x is 2, 2 by 2 is 4, 4 plus 5 is 9. So when the input is 2, the output is 9. So we're trying to find it the other way, where if I gave you the output was 9, what would be the input? That would be the inverse function. Okay, so the first thing we do is we set it up so that instead of f of x maps onto 2x plus 5 as we have here, we use the y notation, so y is equal to 2x plus 5. We're then trying to rearrange this equation so that we can get x is equal to something. So hopefully you can see here we have 2x plus 5 is equal to y. So in order to get rid of this plus 5, we need to minus 5 from both sides. So minus 5 and minus 5 from this side, which means on the left hand side I have y minus 5 is equal to 2x, because this and this will cancel. Again, quick look at the right hand side, I can see I've got 2x, and I need to get rid of the multiplied by 2. The inverse of multiplying by 2 is to divide by 2. So I'm going to divide by 2 both sides. If I do that, I'm going to end up with x is equal to y minus 5 over 2. And most people like to see it the other way, so if you want, you can write x is equal to y minus 5 divided by 2. Now, just to finish this off, we change the y and x round, so what we have now is y is equal to x minus 5, 2, and y then we write to be f to the minus 1 of the function x is equal to x minus 5 divided by 2, and we then have finished. Now, just to double check, we said that once we put 2 into this function here, if you remember earlier in the slide, I got an answer of 9. So let's put 9 in here. We get 9 minus 5, which is 4. 4 divided by 2, which means that I would have gone back to my original, which was 2. That's the inverse function. So let's have a look at this example. It says that the function is defined by f of x is given by 2x plus 1 over x minus 1. And this means that x is a member of all the real numbers except 1. That's what this little / means. And you can see if I put 1 into this, I'm going to get 1 minus 1 on the bottom, which means we're going to get division by 0. And a division by 0 is never a good thing in maths. Okay, so let's have a look at the question. It says express f to the minus 1 x in terms of x. So that means it wants us to find out the inverse function. So the first thing I did last time for the inverse function was I changed the f of x to y. So I now have y is equal to 2x plus 1 divided by x minus 1. And what I need to find x is equal to. So you can see I have x minus 1 on the bottom here in the fraction, and I don't really want it. So I want to take this across and get rid of my fraction. So I'm going to multiply both sides by x minus 1. If I do that, I'm going to get y multiplied by x minus 1 is equal to 2x plus 1 on the right hand side. So here, look, what I've done is I've multiplied both sides by x minus 1. If I do that, that's going to go up to here. And multiplying the right hand side by x minus 1 is going to make this disappear. Okay. The next thing I'm going to do is I'm going to multiply out the bracket on the left hand side. So I'm going to get xy or yx minus y is equal to 2x plus 1. So this is just a skill in rearrangement now. I want to get x's on one side. So I'm going to take all the x's to the left hand side and anything that doesn't have an x, i.e. this one, over to the right hand side. So I want to try and take this one across to this side. I'm going to try and take this across to this side. Now I could have, if I wanted to, I could have taken this xy across to here and this plus 1 across. I've just decided that I want to take the x's over to the left here, and that's entirely up to you. So my next stage looks something like this. I've got xy, and then I have minus 2x, and I'm going to take that y across, so it's going to be equal to 1 plus y. So just to show you again, this has come across, this is a positive 2x. Take it across, it's a minus 2x, I have to do the opposite, or the inverse. And what we have here is minus y going across becomes a positive y, because again it's the inverse of negative. I've got x here, and I've got x here. So the only way I can get x on its own here is to factorise, so I'm going to factorise the left hand side. If I do that, I'm going to take the x out, and I'm going to end up with y minus 2, and that's still equal to 1 plus y. And again here, just to show you, x by y will give me the xy, and x by minus 2 will give me the minus 2x. I now have x multiplied by this bracket, and I want x on its own. So in order to find x on its own, I have to do its inverse, or its opposite, which means I'm going to divide both sides by y minus 2, which means on the left-hand side, I'm left with the x, and then on the right-hand side, I'm 1 plus y divided by y minus 2, and I'm now done. So I could write this now as f to the minus 1 of x is equal to, and don't forget, when we finish this, we change all the y's for the x's. So this is now going to be 1 plus x over x minus 2. And that there is part I done. Now part II states, or asks us, to express f by f to the minus 1x in terms of x. Okay, so f by f to the minus 1 x. Okay, so that means that we are going to do the inverse function, or find the inverse function, which we've already done over here, and then we're then going to stick it into the f of x function, which is this function here, and see what happens. Now, I want you to think what's going to happen here, because if we put an inverse function next to the original function, because this is an inverse with the function, this should all disappear, and we should be left, when we put it all through, we should be left with x. So let's see if that happens. Okay, so f to the minus 1x, we've just worked out down here. Okay, which means that through my f function, I'm now going to be sticking 1 plus x over x minus 2. So that there needs to go through this function here. So wherever I see an x, I'm going to replace it with this. Oh, great. This is going to be fun. Okay, so let's have a go. So I've got f of x, so we've got 2. And then what we've got to put is the x. So I've got 1 plus x over x minus 2. And I've got plus 1 all over. And I've got x again, which is 1 plus x over x minus 2. Put that in a big bracket for you. And we've got minus 1. So let me just show you what I've done there. I've got to put this through this. So wherever I see an x in this, I need to put this big bracket here. So I've got 2, 2. X, well, it needs to be this bracket here. So that's my x plus 1, which is here. On the bottom, I've got x, which is, again, this big, or this horrible fraction. Okay, minus the 1. And now I've got to try and tidy this up. Okay, so how are we going to do that? Well, the first thing I want to do is I want to get this top, this numerator here, I want this to be over a common denominator. Okay, that's the first thing I want to do. And then I'm going to do exactly the same on the bottom. Now, hopefully you can see this is over x minus 2. That means I'm going to have x minus 2 on this. And likewise, I'm going to have x minus 2 on here so I can combine them. So I'm going to multiply this here by x minus 2 on the bottom of the fraction, which means that I have to multiply the top by x minus 2, because whatever I do to the bottom of a fraction, I have to do to the top, so it doesn't change its form. And likewise, I'm going to do exactly the same to this here. I'm going to multiply the bottom by x minus 2 and the top by x minus 2. Okay, so that now means that I've got x minus 2 as a denominator and a denominator here, likewise here and here. So now what I'm going to do is I'm going to multiply out this. This is a bracket here, so 2 by 1 and 2 by x. If I do that, I'm going to get 2 plus 2x. And I'm going to multiply out this bracket here, so plus 1 by x plus 1 by minus 2. And that's going to be plus x, and it's going to be minus 2. And that's all over x minus 2. So what I've done now is I've combined this x minus 2 and this x minus 2. And the reason I can do that, if I just give you the numbers, if I had, for example, 2/7 plus 3/7, that's exactly the same as 2 plus 3 over 7, which then will give me an answer of 5/7. So that's why I can do that. Likewise, I'm going to do that the second lot, which is here. Okay, so on this side I've got 1 plus x. That's nice and straightforward. 1 plus x. And then I've got minus 1 here, multiplied by x, and minus 1 multiplied by minus 2. So we get minus x and plus 2. So minus x and plus 2. And that's all over again, x minus 2. Now what I'm left here is I'm left here with a fraction over a fraction. And we should be happy that if that's the case, what we do is we flip the second fraction, i.e. this one, and we change it to a multiple. So I'm going to tidy it up as I go along, because obviously I can tidy this, and I can tidy this. So I'll do that. So I've got 2 plus 2x here, plus x minus 2. So that there is 2x plus x, which is 3x, and the 2 minus 2 are going to cancel. So I'm going to end up with 3x on the top there, okay, over x minus 2. And then the second fraction, as we just said, is going to be flipped over. So on the top, I'm just going to put a dot here. I'm going to get x minus 2 on the top. And then on the bottom, if you add those up, you can see I've got 1 plus x minus x plus 2. So we've got 1 plus 2, which is 3. Okay, so we've got 3 there. Now, we can multiply these things together. So I'm just going to multiply the top. So I'm going to get 3x, x minus 2 altogether. And on the bottom, I'm going to get x minus 2 by 3. Okay, this is fully factorized. Okay, so everything's written in terms of its brackets. So let's see what's the same here. Hopefully you can see, do this in blue for you, that the x minus 2 on the top is the same as the x minus 2 on the bottom. So we can change them for ones. And this 3 is the same as the 3 here. So we can change them for ones. And then hopefully you can see that we have 1 times x times 1, which is equal to x. And on the bottom we have 1 times 1, which is just 1. So that means x divided by 1, which is equal to x, which means that we've just shown that this is, in terms of x, it's just x. Now, as I said at the beginning, we'd expect if we put something through a function and then its inverse function, those two things will cancel out, and whatever you put in this case it was x, is what we should get out at the end. So what we just shown there in that last slide is that if we take the inverse function and the function, so the inverse function, and throw it through the original function, what will happen is it'll all collapse down to whatever's in this bracket, i.e. x. But if we did it the other way, where we threw the function through the inverse function, we'll also get exactly the same answer. Of course, that would make sense because the function and the inverse function are right next to each other. That's why we do it, and that means everything's going to cancel. So what does this mean in a sort of geometrical point of view? Well, what we have on this is we have a y is equal to some function of x here, and it just follows this line here. This will continue on. And the inverse function looks something like this. And you're probably wondering how I know what the inverse function is, even though I don't know what the actual function is. I don't know whether it's 2x or x squared, etc. But there's an easy way geometrically to do this. What we do is we draw a y is equal to x line in. This is the green thing. And what we're looking for, essentially, is if I take this point here, you can see here, that the distance from the y is equal to x line and my function x and my inverse function of x, can you see that these, if I take it as a perpendicular, i.e. at right angles to this y is equal to x line, you can see that this distance here is the same as this distance to here. So what this is acting like a mirror line. Okay, so it'll be the same here. So if I put here and I come down perpendicular, then it'll be exactly the same distance over here. So you can see from here, this point here is the same distance from this point here. Now the easy way to remember how to do this is that suppose I had a coordinate x, y. If it's going to be mirrored along the y is equal to x line, what happens is they just switch around. So suppose this happened to be 2, 3, then we can work out that the corresponding one on the inverse function is 3, 2. That makes sense because 2, 3 here, 2 would be my input, 3 would be my output. Well, on the inverse function, 3 would be the input because I'm trying to get back to 2. So, and that's why it's just inverted around there. So, in order to construct a curve which represents an inverse function, we have to draw the line y is equal to x. We might not be given this, but we have to. And then what we do then is we try and take a few more points and try and find their images under reflection. Now this all looks very, very complicated, but I'll go through a quick example on the next slide just to show you what's going on. So the curve in the diagonal opposite represents the function. Function of x maps onto root x, or the square of x. Defined in a domain where x is a member of the real family. Okay, so it's all the real values, and x has to be greater than or equal to 0. So no starting at 0, and x is going to carry on forever in this direction. Okay, it says taking the codomain of f to be the set of non-negative real numbers, find an expression for the inverse function y is equal to f to the minus 1x. So it's saying that it has to be positive. So my y is going to be positive. You see from this graph that all my y's are positive. It's saying it has to be positive, and we're going to try and find the inverse function. Okay, this should be fairly straightforward. We've done this before. So what we end up with is y is equal to root x. And then what we're going to do then is get x on its own, remember? So I'm going to have to square both sides to get or undo this square root. The opposite, or the inverse, is to square it. So I'm going to end up with y squared is equal to x. And then remember, now that I have x equal to, I might turn it around. Quite a lot of people like to do that. I put the f to the minus 1 of x is equal to x squared. So what I do then at the end is I change all the y's for x's, and then this becomes f to the minus 1 of x. So that's what it looks like. Now on the diagram, it says sketch the curve y is equal to f to the minus 1x. Well, this is f to the minus 1x, and I'm going to put in that y is equal to x line. So the y is equal to x line is fairly straightforward. So the y is equal to x, I'm going to put this in purple, okay, is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on and so forth. And I'm going to try and get this as good as I can get it, but there we are, not bad. Okay, that there is my y is equal to x line. Now, what I could do is I could start putting some values in here and join up the curve. And, well, we will do that and we'll see what happens. We'll see how we get on. Okay, so if I put 1 through this, okay, so if I put 1 through this, I'm going to get 1 squared, which is 1. Okay, so if I do 1 through this function here, I'm going to get 1 squared, which is 1. So that means I'm going to get the coordinate 1, 1. And what I'm going to do with that one is I'm going to put this one in blue. So that's going to be 1, 1. That's one of my coordinates. If I put 2 through this inverse function, I'm going to get 2 squared, which is 4. Now 4, according to this, is somewhere that's there, isn't it? So coordinate 2, just go across to 2, go up to 4, so the coordinate there is 2, 4. Now, hopefully you can see that this is a curve, which means there's a good chance that the inverse is going to be a curve, and you can see that this is an x squared. You know it's going to be some sort of curve that's going to be looking U-shaped. So if I draw it roughly, it's going to look something like this. Roughly. I'm not going to get it perfect. Now what I want you to notice here, we talked about the whole idea of the geometric position, or how this works geometrically. Notice that if I take, and this is very rough guys, if I take the distance here and go straight to my y is equal to x line, you can see that that distance there is roughly the same distance as that there. Definitely is here, because they're both on the y is equal to x line, and here, that's on the y is equal to x line as well. Now, if you can see here, I'll definitely do this one, look. If you see this one, can you see that when I draw, I'll just draw this in now, I'll just draw it in yellow. If I draw that perpendicular, that is the same distance as this here. So this distance here is the same distance as this here, and this here should be the same distance as this to here. And don't forget, this is just a sketch, so I might be slightly out, but you can see roughly, especially this coordinate which I can work out, and this coordinate here. And we did say in the last slide as well, this is the coordinates, it's going to be 4, 2 here. And if you look at the coordinate at the top there, we said all we're doing is we're swapping around. This is 2, 4. So we said before that the x and the y's, in this case this was the x and the y, get swapped around. This one's 2, 4 and this one's 4, 2. And hopefully that makes a bit of sense.